So just a brief agenda, going over the start of what our testing is at the UNH-IOL, talking about what the UNH-IOL is, since some of you may not be aware, going over the testing tools and the refactor that we've been going over for the past couple of days, and then what's going on after that. So who here is aware of what the UNH-IOL is? Has anyone heard of us? All right, a couple people, my coworkers know who we are. That's good, I'm glad. So what we do is we're partnered with the University of New Hampshire, and we are the neutral third-party testing service for NVMe.org, working with the ICC, the Interop Compliance Committee. And we test, a variety of different types of technologies. Personally, I work in data center. That's why we're here. So there we do host a bunch of group test events and multi-vendor environments, and just kind of provides a good environment for tons of different types of testing with students as our main workforce. So moving more towards just NVMe and what we're doing here. So originally, we just started off testing just the admin and NVMe-IO command set. And that's because that was just the original two command sets that were out, and only with the PCIe transport. And that's still probably the most popular that we have nowadays, still going. And that's been going on for roughly the last decade, and we've been expanding ever since then. And there's been other talks talking about the importance of Interop and why we need to do it. And I'll just rehash it again, saying, we need to make sure that these devices, when they get into your client's hands, that they'll actually work in any multi-vendor environment. You don't need to worry about if it's actually going to boot up or store data or certain features you might want that need to be tested to make sure they're going to do what they're supposed to do, making sure it just works. This is a slide that I stole from the marketing group, so thank you for letting me take that. Just kind of showing that NVMe is pretty much ubiquitous with storage. It's in all different types of environments, and there's even at this point there's even rotational media. So people think of NVMe as just with solid state drives, but it's going really everywhere to become the language of storage, as has been said before. All right, so jumping on to the actual testing. So we help develop test plans with the ICC, and these test plans are based on the NVMe specifications written by the marketing or the technical work group. So these test plans are originally there's only 2 or 3 if you're doing MI conformance. Just the base conformance and just interoperability, and we eventually added NVMe over Fabrics conformance once that was part of the once that was ratified. So our test plans lag behind whatever the latest features are by about 6 months. So we get all the new technical proposals, take them and turn them into different test procedures, and figure out what we need to do to make sure that they're actually conforming to the specifications. So with guidance from the technical work group and the board of directors, we'll pick out the highest priority technical proposals that are ratified and make sure that they're being tested properly. The process is relatively straightforward. Like I said, it happens twice a year, and we work with the ICC and we work with the technical work group to get things done. All the test plans are created by the UNH-IOL with guidance from the ICC, and we present them to the technical work group and the board of directors to be voted on and make sure that they agree with what our test procedures are. So everything it's written by the IOL, but vetted by the ICC and the tech work group, so it's pretty confident with that there. All new tests are FYI. What this means between FYI and mandatory is that when a drive comes to the lab to be tested on, it doesn't necessarily need to pass this test. And the reason for that is because it's a brand new test that hasn't been really fully vetted out in the marketplace. So we're getting these new features and technical proposals and building tests based on the specification, but we don't necessarily know how it's going to perform in the real world yet without having product to actually test it on. So once we kind of get enough multi-vendors to pass our tests, we'll know that the drives are working properly in the industry and the test is doing what it's supposed to be doing. So I said there was only 2 test plans before. Now this is just from our website that's hosted at the link there. We have a bunch going on. We're on version 17 right now, and there's version 18 already being vetted right now at the time. So, and while that's going on, the next test plan is already starting to get developed. So it's really non-stop, and we're going to keep going and going. Just for 1.0 and 1.4 conformance tests, there's been greater than 50 test plans developed at this point. And there's even more now with the refactor because of command set specific test plans and transport specific test plans. And so the real reason, for all this testing is to become part of the NVMe integrators list. So this is also hosted on the UNH-IOL website, but it is the NVMe list, and the whole goal of this testing is to be, put through a neutral third-party rigorous conformance and interop testing plan, so that way you can prove to any clients or customers that, yes, we are conforming to the specification, and this is what the list will tell them. So it's kind of hard to read, and that's the point. There's a bunch, over 350 on the PCIe and over 80 on the NVMe over Fabrics list. This right here is only 19% of what we have listed, and it's been going on since 2013. So there's a lot going on up there. All right, so now we've talked about the integrators list and what we're doing there. So now we'll just go over what the actual test tools that we're using to do this. So there's the conformance and also interoperability testing. Starting off with just conformance testing, this is based on that NVMe conformance test plan that I talked about earlier. So there's two parts to it. There's the Interact tool, which is on the left, top left corner there. That's just run on Ubuntu Linux on a regular desktop server using just a PCIe slot. And on the other side, there's Link Expert from LaCroix, Teledyne LaCroix. And they are both running tests based on the same conformance test plan, except LaCroix Edition gives us a little more granularity and lower control over certain tests, since we don't necessarily get as much control as we might want from Linux default driver, but it has been getting a lot better over the past few years. On the other side, there's also interoperability. So PCIe interoperability really just consists of making sure that the device works with different CPUs, different host platforms, making sure that the traffic that we send to it runs without any data validation errors. If it's an applicable form factor, we'll do hot swap testing using Quartz technology products, and that's pretty much it for PCIe interoperability testing. Also, we have to make sure we can boot an OS from it. And then Fabrics testing is relatively the same with traffic testing, but we also make sure that we can pull links and shut down switches and targets and initiators, make sure everything comes back in a fabric. All right, more on just testing. So I mentioned Plugfests earlier. So Plugfest, has anyone here attended an NVMe Plugfest? We got one, and also my coworkers, I think they were there. Yeah, so this is hosted at UNH in University of New Hampshire, in Durham, New Hampshire. So we have vendors from all over the world. Well, we used to. I think these pictures are from 2019. So we're still doing these, and everyone comes to us, and it's usually it's a great place for competitors to come together and work together on a common solution. It allows us to test drives and products for the first time on the latest version of the test plan and certify on the latest version of the test plan. And also, the great part about it is if we find bugs or failures, we can debug live on the scene and do firmware updates and not have to go a bunch of email back and forth. So doing them in person is really the best way to do it that we found, and we hope to continue doing that this coming November. So in order to get on the integrators list, we've talked about the different parts. This is just a nice graphic showing the process. So you become part of the NVMe Express organization, so you can participate in the different working groups. And then once you do that, then you will join with the UNH-IOL NVMe testing service. So they are different. You join NVMe.org, and then you join with the UNH-IOL, and then you get access to all of the software that we help develop, and then you can perform your own testing in-house. We'll have back and forths on any potential issues you might be having. You'll send it to us, and we'll test it and send reports to you showing what you might be passing, what you're failing, and then you can present that to your customers, showing that here's what our features are, here's what we are supporting, here's what we're not supporting, here's where we might have some issues, and kind of work with them on that. And then at your discretion, we can post on the integrators list when you have the product launch. That gigantic list. All right, so just talking about early, when I say early, it really means pre-2.0. So initially with just PCIe, there's conformance and interoperability. And for NVMe over Fabrics targets, there's conformance and interoperability. But for an over Fabrics switch or initiator, we're really just doing multi-vendor interoperability testing, and that's just swapping with different NICs, different switches, different hosts to make sure that it's working as expected and shutting down properly, coming back automatically. It doesn't always happen, so we want to make sure that with different vendors that they'll actually work properly once it gets out into the industry. So with our conformance testing, we're always trying to test the latest and greatest TPs, technical proposals that are being produced. And with that, we find plenty of bugs both in devices and sometimes in our tests, and that's good because we want to work together to make everything better. We'll always be communicating with the vendors to make sure that any potential failures are being corrected before they get pushed to mass production. And with all these new features going on, there was a presentation yesterday that just talked about how there's been 30, I think, since June or earlier this year. So it's really never stopping. There's always more and more things to be going after and trying to implement to make sure that vendors are testing them and implementing them properly. And interoperability testing is, we are the UNH Interoperability Lab. So a lot of people, that's really the main thing we do. So we'll work in various environments. recently there's been issues of unique identifiers and UUIDs not being unique. So that might be causing problems at scale. So we're making sure to pay close attention to that and making sure that they're being properly implemented. And then I mentioned earlier just about PCIe versus other transports and the complexity there is there. So PCIe being usually straightforward, but then with other transports like RDMA and TCP over IP, there's lots of different things that could possibly go wrong and make it a little more complex to test. So that's really nice when you have PlugFest and we have the Fabrics vendors with us hands-on. All right, so anyway, going on to the refactoring effort. So there's been presentations last year about the refactoring, but is everyone here, or who here's heard of the refactor? Most people, I think? Yeah. Oh, good. All right, yeah. All right, so really, I won't get too deep into it since there's been other people talking about it, but the idea of breaking apart the specifications to make sure that it's extensible, that people can pick and choose the parts that they need and leave behind the parts that they don't need for the NVMe technology. With that kind of reshuffled everything for us since we were just going based on conformance and interop, and now we need to make sure we have test plans for each transport and each command set, as there were new command sets introduced with NVMe 2.0. So here's just a quick visual of what changed for us. Like I said before, it's pretty straightforward in conformance, just NVMe conformance, but then it broke apart into both having admin and ZNS and then admin and NVM, the two IO command sets that exist now, as well as the PCIe conformance transport. They used to all be in one, so you had to make sure to separate it all out to make it easier and align with the specifications that are being produced. And then for over Fabrics conformance, we broke it apart from initially it was just, there's another group of TCP tests, and now they're completely separate. So that way it keeps it really easy to know what we need to test based on what transport we're going to be running. So yeah, so at this point with new command sets, ZNS, NVM, and key value are now defined, and upcoming will be computational programs, computational storage. We're waiting to see when that will be dropped so we can start implementing tests for that. Waiting to see who is actually going to be implementing it. Same goes for key value. But the transports are pretty well defined at this point, and the most popular is still PCIe, and that seems to be what will be going on for at least the near future. We'll see what changes from there. And then we still have the same testing for TCP over RDMA. With TCP and RDMA, the drives and the targets still go through the regular base conformance test, the admin test, but there's also the additional requirements that are set upon in the actual over Fabrics TCP or RDMA transport specifications. So some new 2.0 features that we were testing in our latest release of the test plan. So we added tests for a copy command in NVM and ZNS. There's a bunch of new CNS identify values that were added in 2.0 that we added a bit early in 1.4 next that caused some issues. So that's just an example of when we see failures that might not necessarily be the drive's fault. We communicate and we'll get emails and we'll talk and work through it. And it turns out that these features weren't necessarily all fully ready for the market, and that's why these tests were FYI. So there were failures, but we were not going to be stopping certification just because the drives are not quite ready yet. There's also the command group control and command feature lockdown that we've added as well. So that's really the three big ones for 17, and there's even more going on in 18, which is now being looked at. So there's a bunch of new tests. For 17, that was the first one we did the refactor. There's really roughly around 20 new tests, and the main splash was that it was broken apart. And now that we've established that, we have to get back into the massive new test production. So, there's these TPs that were listed out here. We also addressed ECNs 101 and 102 in TP 18, test plan 18, not technical proposal. And we added, 21 tests for ZNS, more test cases in TCP. So it's really, the ball is rolling very fast. So at this point, we've got, I'll round up 850 tests, 849 tests overall that are being written or implemented. So it's pretty rigorous depending on how many transports or command sets you are trying to support. If you just want to test NVM and admin, it can be straightforward. But if you're trying to do a JBOF or some sort of Fabrics device, it might get a lot more complex. And we'll make sure that everything is running as expected. And if it's not, we'll work together to make sure it does. So beyond, keep going. This is a slightly out-of-date marketing working slide that I got from a working group from 2 weeks before FMS, but it's the latest I could get. So yeah, there's computational programs that will be coming out later. There's a couple of new features that we're going to be looking over, like key per IO and cross namespace copy that we're hoping to start implementing tests for. Also, there's presentations about the OpenFabric's discovery automation with IP. So that'll be something we're going to try to pursue and hopefully be able to start testing in our own multi-vendor environments in our lab. So why does this matter? At the end of the day, we're all trying to work together to make sure that the storage industry performs and works better together. If stuff is actually going to be put out in multi-vendor environments, we want to make sure that it will actually conform to standards. You don't have to worry about random oddball drives failing or causing issues for your servers. We want to be able to fix any potential problems before the market release comes out. That's why we are always communicating with the vendors who are sending drives to us. And we work directly with the the technical working group, to make sure that we're addressing the most important features that people actually want and are going to be implementing. So there might be a lot of things that are just being, they're important for a given company, but maybe not widely adopted. So we want to make sure we're tackling the most widely adopted potential issues. And then once testing is all completed, you'll be able to get standardized reports that show what you are passing, what you're failing, what features you are actually supporting, and you can present that to whoever you may want, and that will show them what you are, what they can have confidence in your product. So yeah, really at the end of the day, we're trying to make sure that you can certify your device with confidence that it supports the NVMe specification to the key. Yeah.